Hello, Bookmans universe. I am here with the wonderful Emily Levesque today. She is an incredible astronomer and author and violinist and a bunch of other really amazing things. I've listened to several interviews from various people on Spotify, and she has a great voice. So I'm really excited to get to know her. Emily, why don't you go ahead and introduce yourself?
Yeah, so I'm Emily Levesque. I'm an astronomy professor at the University of Washington. I'm the author of this new popular science book, The Last Stargazers, which you can see Baby Yoda happily modeling in hardcover, and it recently also came out in paperback. Um, I at the University of Washington, I teach and lead a research group, and we study the biggest stars in the universe. We study how they evolve, how they sort of grow old, how they die, and these are the stars that when they die make a supernova and leave behind something like a neutron star or a black hole. So I'm really interested in these sort of late stages of stars' lives and the weird physics of how they work. I also really love the stories of our field. I primarily work with data from telescopes and will travel to telescopes to get this data. So I wrote The Last Stargazers to sort of give people a behind the scenes tour of what it's actually like to have a kind of unusual job like this and work at some of the best telescopes in the world.
So amazing. So tell us your astronomy origin story. How did it all start?
So I am one of those people where I've literally been interested in astronomy since I was tiny. When I was two in 1986, Halley's Comet made its most recent close flyby of Earth. For folks who don't know, this is a comet that is visible from Earth about every 75, 76-ish years. And when it passed by, my big brother Ben, who's 10 years older than me, had a school assignment to go out and observe Halley's Comet. So my whole family went out into our backyard in southern Massachusetts. I was little, I was tired, I was fussy, I was cold, I did not want to be out in the dark until they pointed me up, and apparently I was then just mesmerized by the night sky. They like got me to look through our little backyard telescope even though I was tiny. And from then on, people would ask me what I wanted to be when I grew up, and I would say, "Oh, I want to be a ballerina or an astronomer," or "I want to be a firefighter or an astronomer." And then when I got older, "Well, I want to be a violinist or an astronomer, a marine biologist, or an astronomer," just stuck. And when I got to college, I majored in physics, knowing that astronomy, to get into astronomy, I would want to start with physics. And it just stuck and stayed that way from there.
So could you tell me a little bit about what it takes to become an astronomer? What school you have to go through? Any other connections you need to make or anything of that sort?
Yeah, I really didn't know this when I was a little kid saying, "Well, I might be an astronomer," because I didn't know anybody who was a professional scientist. That's actually not that weird because out of these 7.5 billion people on our planet, about 50,000 of us are professional astronomers. It's a very rare career. And all I knew was that I liked space. I saw people in movies who did space professionally, and it sounded neat. And I got my first glimpse of what that meant when I was about 8. We went to a little astronomy open house at the small college near, not too far from where I grew up. And there was an astronomer there, and I told him, "I want to be an astronomer. What should I do?" And he said to me, "Take all the math you can." And I apparently went, "Okay," and then went off and took as much math as I could. I say the update for that today is take all the math you can and take all the computer science you can, because math and programming are really the languages that we do science in these days. So that was sort of the school basis. In college, I majored in physics at MIT. I adored MIT, but they didn't have an astronomy major, so I majored in physics and then concentrated in astronomy. We have heaps of astronomy majors at the University of Washington, and that's usually the first step on the path to professional astronomy. And from there, you can work on the observatory staff or work with sort of large telescope collaborations. You can go on to get a master's or a PhD. I have a PhD because I knew that I wanted to be a professor and teach at the university level along with doing my research. But it's a pretty fun job. It takes a lot of preparation. It takes a lot of work to get to a sort of long-term permanent position in the field, but I'm very glad that it's a challenge I took on and then stuck with.
Absolutely. Oh my gosh, what a cool story. I mean, you just started from this little child, and it just grew and grew and grew, and now here you are, one of the influential people of our time. You've done so much work, and you've also gotten a chance to travel to several different observatories, you were saying, one of which was near where we are, of course, in Tucson, Arizona, the Kitt
Yeah.
Peak National Observatory. Would you tell us a little bit about that experience?
Absolutely. First of all, I love Tucson. I've gotten the chance to visit there a number of times for my work, and it's one of the sort of hubs of astronomy research, I'd say, in the world. I'm very sorry that I can't be there in person, and I'm really looking forward to the next time I am there. But Kitt Peak was my very first time visiting a professional observatory, and this happened after my sophomore year of college when I did my first summer research program. And I did this with a colleague who I still collaborate with to this day, who works at Lowell Observatory in Flagstaff in northern Arizona. I came out to Arizona to spend a summer in Flagstaff, but we started meeting in Tucson and heading to Kitt Peak, where we had 5 nights of telescope time assigned to us there to sort of kick off my project. And what I remember most about that visit is actually a story that ultimately kicked off why I wrote the book, The Last Stargazers, because we drove to the mountain, we showed up at the observatory summit, we kind of dropped our stuff off in the dorms, and we went into dinner before our first night of observing. And there were other astronomers there having their second meal of the day, which is about at 5 or 6 p.m. This is well before the lunch that you eat in the middle of the night. And Phil introduced me to everybody that was sitting down to dinner, saying, "Everyone, this is Emily. She's a summer student working with me, and this is her first time at an observatory." And everyone immediately said, "Oh, cool, like welcome, come on in. Remember to order your night lunch, that extra meal you eat late at night. Order it now, but don't eat it too soon. You'll get hungry at 10 and wait until midnight." And then someone else said, "Okay, well, you're gonna want to drink a lot of coffee to stay awake, but stop drinking it at 3 a.m. or you'll never go to sleep once your observing runs over." And then someone else said, "You know, a good thing to know around here is that we have these little scorpions and they can be dangerous. There was a woman who was observing and a scorpion crawled up the inside of her pant leg and stung her." And then everybody picks their feet up off the floor. And then someone else says, "Well, I know a guy who had a raccoon crawl into his lap while he was observing and he just pet it until it went to sleep." And then someone else is saying, "I know a guy who was in a dome when it was struck by lightning." And they all started pinging stories back and forth. And I was sitting there with my dinner just kind of like, and I really couldn't decide if I wanted to keep listening to them telling these stories all night or whether I wanted to go run off and start making my own stories. And I learned later what the storytelling fest had been, because they loved hearing each other's stories, but it was also a way to kind of welcome the newbie to the field and tell me, like, here's kind of what you're getting into, and here's some of the wacky adventures that you have in store. Here's a little window into what this very unusual job is like. And that's why when I got the idea for The Last Stargazers, I realized, you know, telling a general audience these stories and sharing these kind of wacky tales of what it's like behind the scenes of an observatory and it's what it's like to do this job is a great way to sort of introduce everyone to how scientific research works, how we study the universe, what makes astronomers tick. It just seems like a great window into teaching people about the science as a whole.
Yeah, absolutely. And you make it so accessible too. You make it so it's like plot driven in a way, but also so educational. I'm currently digging into it right now, and I'm loving every second of it. Can you tell us a little bit about the writing of The Last Stargazers? Your writing process and etc.
Yeah, I actually got the idea from the book for the book from talking to an editor who later went on to become my agent, who'd asked me to sit down and was just sort of saying, "Have you ever thought about writing a popular science book?" And I remember telling him, "Oh, no, I don't have any ideas for one, but maybe someday in the far, far future, I'll want to write one of these. So let me learn a little bit about what the field of popular science publishing is like." And he said, "Well, if you did write one, what would it be about?" And then the idea for the book came out of my mouth, which shocked me. But it was based on that first sort of set of storytelling that I heard at Kitt Peak and the many other tales that I'd heard pinged around in the field over the years. When a group of astronomers is, having some beers after a conference night or taking a break during a committee meeting, people will tell tell tales like this about, did you hear about that time when so and so did this at a telescope, or here's the wackiest discovery someone's made, or even here's the most incredible way in which someone's been wrong. There's, valuable science to be learned along with the stories. And I realized that by gathering these stories from my colleagues, I could make a very good tale of how science works, the science that we do, the cool discoveries we've made, and also how our field is changing, because the way we use telescopes has evolved a lot over even the past few decades, let alone in the, roughly 80, 90 years that the book winds up spanning. So I interviewed more than 100 of my fellow astronomers, more than 100 colleagues for this book. I have hours and hours of recordings of people telling me their biggest adventures at telescopes, telling me about the biggest stories they've heard from others, telling me who else I should talk to, answering a few questions from me about the biggest changes that they'd seen in the field, or, for example, what they thought would surprise a readership the most about what our jobs, like what's the biggest disconnect between what people think astronomers do and what we actually do. And the most challenging part of the book was then assembling all of those stories into an overall book. I knew I didn't just want it to be an anecdote collection. The book has to have an arc and a progression. It follows my own career a bit. It follows the evolution of astronomy. I also knew that I had far more material from my colleagues than I could ever fit into a book. My first draft of the book was longer. I had to cut so many stories that I thought were wonderful, but of course my editors were right, and what's come up is a now much very cleanly and neatly organized sort of summary of what life is like in the field. But gathering those interviews and then compiling them was so challenging, but so fun, and definitely the most satisfying part of the process.
Oh, I love that. That's amazing. So, outside of being an astronomer, of course, or a professor, what other hobbies are you into?
What other hobbies am I into? It's been actually interesting to watch my hobbies evolve over the past couple of years, because some of the things that I really love doing have been a little more difficult these days. I really love traveling, and astronomy introduced me to that. My very first time leaving like the North America, my very first time flying to another country, I was visiting Chile, one of the best places on the planet for astronomy, for an observing run. But after astronomy sort of sparked this, I've really loved sort of exploring our own planet, enabled nicely by our job, which has been a little more difficult these days. I've also played the violin for a very long time, and I've played with both of the University of Washington's orchestras, which similarly hasn't happened much in the past couple of years, and I really miss playing music with people. On the flip side, I can at least keep playing the violin on my own. I like, this seems like a random hobby possibly, but I really like to cook, and I've gotten a chance to get really good at it in the past couple of years, because to me there's a nice science to it of following some instructions and experimenting here and there to see what you get, but it's much more finite than the work I do every day. I work on research projects that have been going on for years, for in some cases for like over a decade, and after making a tiny bit of progress on a huge project, it's sometimes nice to be like, I've got a tomato and onion, and at the end of this process there's going to be tomato sauce, and it's going to take 45 minutes. So it doesn't seem too different than research to me, but the timescale is very satisfying.
That's too funny. So what are you watching right now, movie wise or TV shows?
Oh, movie and TV show wise. So we try to, in my house, we try to sort of spin through a different variety of things so that we have, something based on whatever our mood is. We'll do, Great British Baking Show on cold nights and things like that. We just finished watching actually the second season of Lupin, which is this wonderful French show it's sort of a modern retelling of this sort of classical Sherlock Holmesian literature character in French literature, which is really interesting. We also just finished the first season of Arcane. And we will also loop through another hobby that I really enjoy is cycling. And in winter in Seattle, despite the fact that it's sunny out today, it's usually not a great time to bike outside. So I have my bike on a little indoor trainer, and you have to put TV on or else you feel like you're on a hamster wheel. And we're watching, a season of Cobra Kai. We're working through things like old reruns of The Amazing Race, because if you can't travel, you can watch people travel. But I really have a broad variety of shows that I like watching.
Do you watch any sci-fi or like space-related TV shows or movies?
It's funny because I find some of these space related, the shows that seem to be based on, actual, like the profession of astronomy or the profession of academia, aren't quite relaxing. They're a little too close to home. I, for example, have not yet seen The Chair, the TV show, and I've only seen a little bit of Don't Look Up. But I do enjoy sci-fi shows or fantasy shows. I have no problem necessarily suspending my disbelief with them
Yeah,
a little
sure,
bit,
sure.
but I can't pretend I'm any kind of sci-fi or fantasy connoisseur
Yeah,
necessarily.
that makes sense. Yeah. Do you ever notice any sort of like just parts of science related TV shows that are just absolutely wrong and it bothers you or anything like that?
So, so I will sometimes have things that bother me in shows, but I don't think it's necessarily what people might expect. I'm a scientist, but I'm also a storyteller. I have no problem just introducing random wacky science if it serves the story or makes the story good. There's a great example of this with the movie Interstellar, which I see you have on the bookshelf next to you.
My favorite movie.
Where
I love that
so
movie.
there's this wonderful interview with Kip Thorne, who's a brilliant theoretical physicist, and who is Interstellar is sort of the culmination of a story that he had wanted to tell for a long time. And they're very careful with a lot of the science in that movie. There's a famous story about how their image of a black hole came from putting, physics calculations into a Hollywood budget visualizer and producing the amazing picture of a black hole that we see. But someone interviewed him and asked him about everything and how careful and accurate it was. And there's a scene where the characters are on a planet with these giant floating ice clouds. And Kip Thorne says, yeah, that's not going to happen. That the physics of that is wrong. But it looks so cool. And you have to be allowed to do that in a movie. So I don't mind the big things. I get bugged by the unforced errors, like when there's a blatant science error that didn't even need to happen. The most memorable one that I can think of is actually from the TV show The Flash, for folks who know it. And there's a interesting storyline at one point where the characters are looking for, it's a sort of comic book style villain. They're looking for a villain whose superpower is to freeze things. And they have an infrared imager so they can find hot things. And someone says, instead of looking for his infrared heat signature, we can look for his ultraviolet cold signature. And if you know physics, this is actually exactly backwards. It's a super easy mistake to make. We're all used to sitting in, our shower or looking at our kitchen faucet and seeing a red hot water faucet and a blue cold water faucet. But in actual physics, the hotter something is, the bluer it glows. Our very hottest stars are bright blue, and the coldest ones are sort of this like dim red ember-like color. So I remember seeing that in the show and going, if it was ultraviolet, it would be really hot, and you didn't even have to do that. So that always bugs me a little bit. I also sometimes get bugged at how scientists are depicted in shows, because clearly we have no problem letting our nerdiness shine through, but I don't like the depiction sometimes that we're incapable of having a regular conversation, that we are, so completely off in our own worlds that we don't want to, do things like go on bike rides and cook food and have fun. And I like seeing scientists who are just shown as enthusiastic and energetic and like eager to explain the world around them to people because they love how cool it is, as opposed to just sort of weirdos. So I like seeing a more realistic and more broad brush portrayal of scientists than will sometimes show up in shows.
That makes a lot of sense. Yeah. So what about books? Are you a reader?
Oh, yes.
Oh, yes. Okay. What books are you reading these days? Are there any that you would recommend right off the bat?
There's a wonderful book that I just finished reading. I actually did a book event with the author recently, but I just finished reading Sasha Sagan's For Small Creatures Such as We, which is a fascinating book looking at sort of ritual and meaning in everyday life. Sasha Sagan's parents are Anne Droyan and the late Carl Sagan, so she had a really interesting perspective from her parents on sort of growing up with science and the mentality of a scientist as a way of life and as a way to sort of mark the changing world around her. And she writes a really interesting book on how a wide variety of religious traditions from very different parts of the world, and and with very different histories will all mark some of the same natural steps in life. Everybody has a way to mark birth or death or the moment of coming of age. We have things that we celebrate on a weekly basis or a monthly basis, or we'll mark the autumnal equinox or the winter solstice. And her book on that, on saying, for those of us who are religious and have this framework, here's where it comes from. For those of us who are not, but still want to, find meaning in a really interesting universe, here's the, here's the ways that we can recognize the amazingness of our world. It's just beautifully written. And it's also part memoir. It talks a bit about her experiences growing up with her dad and sort of how she's now built a life of somebody who is not a professional scientist, but who very much lives by the tenets of science. I thought it was wonderful.
That's amazing. Have you ever, so you've been to Tucson, you've been to Flagstaff, but have you ever been to a Bookmans?
I think I have. I'm pretty sure. So I spent an entire summer in Flagstaff, and I've visited there a number of times since then. I've had less time in Tucson because I tend to be there for a work visit, but I'm pretty sure I've been to the Bookmans in Flagstaff.
Okay.
And yeah, I'm a sucker for bookstores, so I can't imagine I didn't make it in there at some point when I was there for the summer.
When you are in your favorite bookstore, is there a specific section that you tend to frequent most?
I always look around the science section, the section that my book would be in. There was a point where I was doing this for, personal research. I remember admiring all the book covers going, I wonder what mine's going to look like. But I also just like other nonfiction science or natural history books. I just started the book Fuzz by Mary Roach, which is this very interesting exploration of times when the animal kingdom and the legal world have intersected. I think the book opens with a story of folks hundreds of years ago trying to take some caterpillars to court because they had destroyed crops or something like that. Or, situations where a bear breaks into someone's house. What do you do? Which is just such a quirky topic that I don't know a whole lot about, that I love people who can write about something very far separate from my own experience, but make it really engaging. I also love things like travel anthologies. And again, you can tell this from the way that I wrote my book, where I tried to pull in as many people's stories as possible. I love stories that have been assembled into a cohesive, bigger story, and things that really take that sort of large-scale global perspective. So those are my two favorite areas to look around.
Nice. I did want to ask you a question going back to the movies that we were talking about earlier. So are there any space-related movies that have certain futuristic sciences in them that you would want to see in real life in the future?
I mean, aside from the fact that we all want lightsabers.
Well, okay.
This is... I like to think that this answer is hopeful and not sad. One of my favorite movie depictions that I've seen recently was actually watching The Martian. And The Martian is not set very far in the future. It's set in a world that doesn't look that different from the world we have today, but it's imagining a world in which we have regular crewed missions to Mars. And there's scenes in that where they show JPL, the Jet Propulsion Laboratory, and they show NASA just a little bit in the future. And it's clearly a world in which NASA has an amazing budget. And that's what I want to see happen. I remember watching that going, God, what if we poured this much time and love and effort and support into space research, and look at the sort of things that we can do in this movie. Imagine what we can do in real life. And we're already seeing some of the cool sort of next generation advances of well-funded scientific research. But I remember watching The Martian going, boy, NASA looks great with a big budget. We should do that.
That's too funny. So tell us a little bit about your successes as
my successes. My successes. I think the coolest, I can talk a bit about the coolest discovery that I've ever gotten to be a part of, because I actually tell the story in The Last Stargazers, and I tell it specifically when I'm writing about sort of how astronomy has changed. I mentioned before that I study the most the biggest stars in the universe and how they die. And as part of this, my colleagues and I actually discovered what we think might be the first example of a totally different type of star. And to understand why this star is weird, it's worth just briefly talking about how regular stars work. So a star like our sun is able to be a star because it is fusing elements in its core. It's basically running a little fusion reactor that is able to generate energy that supports the star against just sort of collapsing under its own gravity. Our sun is fusing hydrogen to make helium. When stars start to reach the ends of their lives, they fuse helium to make carbon. But they'll fuse one element into another, and that's how they work. We discovered what we think is a type of star that doesn't have a fusion reactor in its core. What it has instead is this very strange little lump of dead star that's supported by principles of quantum physics. And it actually happens because this is the leftover remnant of a star that's died. Its core has collapsed. It's crunched into this tiny, dense thing called a neutron star. A neutron star, for reference, is about the size of a small city. But if you scooped up 1 teaspoon of it, it would weigh more than Mount Everest, just to tell you how extreme they are. And because they're so dense, there's actually quantum physics principles that start to come into effect to keep them from just collapsing in on themselves indefinitely and making black holes. Kip Thorne, the same person behind Interstellar, and a woman named Anna Zhitkov predicted these weird stars back in the 1970s that look outwardly just like normal stars. They actually look like big, puffy red stars called red supergiants. If you've ever seen Betelgeuse in the night sky, you've seen an example of a red supergiant. So they look like those, but they have these weird quantum physics-supported cores. My colleagues and I, working with Anna Zhitkov, actually found what we think is the first evidence of a star like this. And they're difficult to spot because they look normal. But if you look very carefully at the chemistry of their outer layers, you can say, oh, there are some signs that something's different inside the star, that there's a neutron star in there. And the full story of how we found these stars, how we went looking for them, and how we wound up making the discovery is told near the end of The Last Stargazers. But we are still working on trying to find more stars like this and trying to explain exactly how they work. But the idea that we could have found a totally new way for stars to work, just a new way to explain the physics of how a star can even exist, is super exciting. So that's probably the coolest research that I've gotten to do.
I cannot wait to learn more about it in the book. I get that little touch of the very beginning of the story, in the first like 20 or so pages, and it
Yep.
really entices you. You wanna dig into it. But so what about your failures? Do you have any mistakes that you've made in the past that yeah.
Oh, absolutely. Um, I think I think the biggest I almost don't like calling them failures because they're such a typical part of research, but I think the most discouraging parts of being a scientist and of working in the field that I do are just the cases of rejection or of, say, writing a proposal that doesn't get funded or applying to a job that you get turned down for. It's really easy to look back at a lot of people's careers and like, I have a job that I adore at the University of Washington. I've written this book that I'm so happy about. And this book was turned down by heaps and heaps of publishers before my wonderful publisher, Sourcebooks, wound up ultimately being the group that I wound up working with. I applied to all sorts of jobs that I didn't get before I wound up at the University of Washington, which is a wonderful place. But people sometimes forget how much rejection and how much frustration and how much, oh God, is anyone ever going to hire me? Is anybody ever going to publish this book? Am I ever going, are my ideas any good? You spend a lot of time asking yourself that and being frustrated with yourself and sometimes talking yourself up and going, nope, I believe in myself. And other times going, well, I might as well keep going. So there's definitely frustration that comes. And it comes in the form of research too, when you write a piece of code that doesn't work, when you get halfway through writing a paper and then find a massive mistakes that you've made that would completely change your research results. So there's a lot of discouragement alongside the positives. And the nice part is remembering the positives and knowing, we'll come back to that again. There's going to be more of that. I think there's some quote that I remember seeing recently of success as being able to go from failure to failure without stopping. And that sounds a lot like research as a whole. But the positive parts make it worth it. It doesn't make the moment of frustration any less frustrating, though.
Oh, sure. I'm sure. And that's with everything that you do, really.
Right. Yeah.
So uh, this is according to a website. So hang on. A large stony asteroid will safely pass Earth on January 18th, 2022. The estimated size is 3,200 feet, which is 2.5 times the height of the Empire State Building. Uh, do you know anything about this? And will you be watching the skies on January 18th?
I will not be watching the skies because I have so many colleagues who do this for a living and who I know are keeping an eye on these sorts of asteroids. As I recall, too, this asteroid is making what we call a close pass to Earth, but astronomers will very often talk in terms that are a little bit misleading in terms of what we actually mean. I would, for example, describe the star Betelgeuse as nearby. Betelgeuse is more than 600 light years away. But on the scale of the universe, that's, the backyard. So an asteroid passing close to Earth means that it's, fairly nearby, but it's not, skimming by our atmosphere. It's going to be, for example, its closest approach to us is 13 times farther away than our moon is.
Oh, wow.
So we've got plenty of breathing room. And there's entire groups of folks whose job it is to find and catalog and track and keep an eye on to make sure we're getting the math right. Asteroids like this, because you don't want to, miscalculate and say, oh, it's coming closer than we thought. We are extremely good at doing this and in keeping close track of these. So I will rest easy knowing that this will be a nice pass that gives us a good look at an asteroid, but nothing to worry about.
Yeah, I'm excited to see at least, the footage or pictures or anything of it. It should be interesting at the very least. What
Absolutely.
About, yeah, in the same vein, what about the James Webb Space Telescope? Have you been keeping a close eye on that? I'm very excited.
Yes, sorry, that was a giveaway.
Yeah.
But yes, so myself and I think almost all of my colleagues in the field of astronomy have been watching as James Webb undergoes its just astonishing and really impressive deployment. So this telescope is going to be the successor to the Hubble Space Telescope. I say that even though Webb and Hubble will both be observing and operating simultaneously. They do different types of science, but I think a lot of us look at the James Webb Space Telescope as similar in sort of majesty and scope to something like Hubble. It has been launched to a distance that will ultimately be much farther away than our own moon. It is designed specifically to detect infrared light, so light redder than what we can see with our eyes. It's got a bigger mirror than Hubble. So it's going to give us a totally new perspective on the universe. And it's now finished this very intricate process of being launched, fired out to where it's ultimately going to be hanging out well beyond the distance of the moon. It's unfolded a sun shield so that it can stay nice and cold. It's unfolded its big mirror, which is made up of these golden hexagons that will ultimately fit together perfectly. Now we're just waiting for that mirror to slowly get aligned and for the telescope's cameras to come online before we see its first pictures. But I am so excited to see what this telescope winds up showing us.
Going to be brilliant. No, I on social media I follow a couple of astronomy geeks, and they post daily videos of like what the James Space Telescope is doing, and it's so funny to me because like it's literally just opening up very slowly, of course, which doesn't sound that exciting. But just the fact that it's out there, the fact that it's doing so well, while it's getting over to that place is astonishing, and my anticipation is killing me.
The engineering that goes into it too is just amazing, and I don't think it's possible to overstate how complicated this was. I remember people describing it's like a Mars rover landing every day or something along those lines. People were listing off the number of single point failures that could happen if one part of the telescope's 5-layer, very delicate sun shield hadn't deployed properly, if one of the mirrors hadn't properly locked into place, if the telescope hadn't unfolded itself perfectly, then the telescope wouldn't work, and we would have invested huge amounts of time and energy and money into a telescope that failed. And this is precisely why we invested so much time and energy and money, and why so many people worked so hard on it, because we knew if
it was like a 20-year process, wasn't it?
Oh, I think the total process was even longer than that.
Even longer?
And I mean, the total budget for the telescope wound up being $10 billion. dollars, billion with a B. And it was a number that frustrated a lot of people going, we could have done different science or other science with that money. And that was the resources that were needed to deploy something this big and impressive that worked.
Right.
So we were all biting our nails, waiting for every single point failure to clear. I know we're still not done, but the most challenging parts of the telescope are now up, and it's going to be this wild new perspective on the universe. So yeah, we can't wait to see it.
Oh, so exciting. Do you have a favorite astronomy fact?
A favorite astronomy fact?
Or
Here's
at
one
least
that's
one that
in.
you like a lot.
Oh yeah, here's one that's in the book that a lot of people don't know, and that relates to my research. So, did you know that stars can fake their own deaths?
What?
Yeah. Hi. So when big stars die, what they do is the cores of these stars actually collapse. That little balancing act that I described before between a core that's fusing and making energy and the star's own gravity, at some point that balancing act gets disrupted, the whole core collapses, and then the whole star kind of falls after it and bounces off, and it gives us this huge fireworks explosion that we see as a supernova. That sounds really dramatic, but all of the supernovae that we've seen happening, all of the stars that we've seen dying like this, have been in other galaxies. We actually haven't had a star die like this that we can see in the Milky Way in over 400 years. So in another galaxy, what this looks like is just a star that kind of goes bing and gets a little brighter and then fades away to nothing over time. There are stars that will do that sort of bing. They'll get a little bit brighter, not because they've destructively exploded as a supernova, but because they've just undergone this weird brief eruption where they've puffed off a lot of their outer layers. We still don't understand why stars do this, and we certainly don't understand why some of them do this so violently and dramatically. But there's stars in our own Milky Way and in other galaxies that we've seen hurl off huge amounts of mass. It lights them up. They look, for all intents and purposes, like they've exploded. And then when we go back and look a couple years later, the star's there. It's, the I'm not dead yet of stellar evolution. And these have tricked people before. We've seen a star brighten and said, oh, that's a supernova, and then gone back a couple years and went, well, the star is still there. Probably wasn't a supernova. What happened? I write about studying a star like this in the Last Stargazers, and this is now a whole subfield of astronomy, is studying these big eruptions and stars that hurl off huge amounts of mass like this and trying to explain why they work that way. But I love that they can trick us. The idea of a star exploding and dying sounds like it should be really obvious, and it can be really easily mistaken for something like this.
That's insane. You I'm lost for words. That is so cool. Do you have you are around tons and tons of very inspiring people, I'm sure. Do you have a greatest inspiration?
So I'll admit one that was very close to my mind while I was writing the book was Vera Rubin. So she is the woman who discovered dark matter. And the idea of dark matter had been sort of idly tossed around in the field before. Like, what if there's a mass that we can't see? What if there's this strange phenomenon that can explain odd things that might be happening in the universe? She was the first person, along with her collaborator Kent Ford, to definitively discover evidence showing that dark matter exists. So dark matter is kind of what it sounds like. It's matter that has mass, and we see the gravity of that mass. We can see dark matter tugging on things thanks to the effect of gravity. But dark matter itself is invisible. And I actually think dark matter isn't almost the right word for it, because you imagine something dark is casting a shadow. We can't see dark matter at all. We can't see it no matter what type of light we look for. We don't see X-rays from it. We don't see visible light with our eyes. We don't see infrared light. It doesn't seem to interact with light at all. And we have no idea what it is. We're getting closer. There are researchers today whose entire career is devoted to trying explaining what dark matter is. But Vera Rubin, by discovering the first evidence of this, she saw a slight mismatch in how galaxies were spinning that told us there had to be some extra mass there. In her discovery, she basically created a field of astrophysics. There are, like I said, people whose entire careers, there's entire research groups that are just studying dark matter. She did all this back in the 1960s, which was a really interesting time to be a woman in astronomy, too. She, for a while in her career, was not allowed to be the lead observer at a telescope. That position was reserved for men. Women who observed at telescopes were not allowed to stay in the observatory dormitories, which were men only. So they either couldn't observe or they were just sort of shoved off to like cold, unheated, terrible little cabins somewhere else on the mountain. And she managed to make this amazing discovery while also dealing with all sorts of sort of hurdles placed in her path that her male colleagues didn't have to deal with. She has won pretty much every scientific award that can be given in the field. She never won a Nobel Prize, and I think that's too bad for the Nobel Prize because this means they're never going to have recognized this really amazing research that she did. And she now has a new telescope named after her, Rubin Observatory, which I also write about in The Last Stargazers because it's this amazing new telescope being built in Chile that's going to pretty much survey the entire sky and take a picture of the entire sky over and over again every few nights for a decade. It's basically going to give us a 10-year-long movie of the night sky. And it'll catch every weird supernova or faked supernova that appears and disappears. It'll spot every little asteroid scooting through the night sky. They'll see it move differently compared to the stars. It's going to be this like just powerhouse of detecting anything that changes in the sky. And I love that it's named after her. They could not have picked a better person to name a telescope after.
I love that. What an inspiration. So if you could go back in time to have a conversation with your younger self, is there anything you would say?
I think I would say, if I could go back right now to my younger self, I think I'd say it's worth it. Because like I mentioned, there are plenty of disappointments and frustrations involved in getting to the point that I am now in my career. I got turned down from colleges that I was convinced were the perfect fit for me. And then, of course, I wound up at a college that was amazing. I got turned down for jobs or opportunities that I thought would have been perfect, and I wouldn't trade where I am now for anything. I was the kid that got teased in school because everybody else was, doing soccer and ballet, and I was doing science fair and reading about the moon landing. And I remember wondering if I was very convinced I was always going to be a scientist, but I remember hoping that I would still, get to have friends and, have fun along the way. And I would love to let mini Emily know, like, yes, you're going to meet amazing people and have really cool colleagues and really enjoy the job that you're doing. It's even if you're, a little lonely at lunch right now, it's totally worth it.
Great answer. So I have two more questions for you. This one is a surprise question. Describe yourself in 3 fictional characters.
Describe myself in 3 fictional characters. So, I know that if I asked somebody else to do this, there's 2 characters that they would come up with. Everybody tends to bring up Ellie Arroway, who's the lead character in the book and movie Contact. Mm-hmm. I think she would come up purely because she is the only fictional female astronomer that most people can think of. That said, Contact is it's a great movie. It's a spectacular book by Carl Sagan that I can highly recommend. Somewhere back on my bookshelf, there's my copy with like the first 4 chapters falling out because I've read it so much. And I know that when people do those, little like which Harry Potter character quizzes you are, everybody assumes that I would be, Hermione. And we always get into these arguments then regarding Hogwarts houses and how we actually depict, women who like books in books or movies. And I don't think either of those are bad. I do remember taking some big internet quiz at some point saying, which popular fictional character are you? And they had like heaps and heaps of potential options. And the character that I came up as being most similar to was C.J. Craig from The West Wing. And I swear I would like put that on my resume. Like that's the fictional character that I would like to aspire to be. Um, and funnily enough, shows like The West Wing are another type of show that I like watching just because it's a bunch of really enthusiastic, dedicated people. Like they have their act together. They may not make the right decisions all the time, but they're coming together for some sort of like common purpose, common project. And they actually remind me more of my colleagues and I than a lot of depictions of scientists on TV, because there's that sort of quirky team dedication that I feel like is what happens when astronomers are at their best. So it's not quite, an amalgamation of three fictional characters, but that's the vein I tend to wind up in when people talk about what fictional character I would be.
Totally, totally. So, where can our viewers follow your professional journey?
Yeah, so you can follow more news about the Last Stargazers at thelaststargazers.com. You can also find it on Instagram. It's just at the Last Stargazers. And there's a hashtag that I use on both Instagram and Twitter, which is just hashtag the Last Stargazers. There's a theme. You can also find me on Twitter at EMSQ. So it's the beginning of my first name and the end of my last name. So EMSQUE. And I have a professional website at emlevesque.com where you'll see updates on the cool research that my research group and I get to do, and updates on things like new projects. So those are the main places you can find me.
Awesome. Yeah. Well, Emily, it has been such an honor getting to know you today. Thank you for joining us for this little virtual interview.